Hello, welcome to the Python tutorial for the class Mathematical Foundations of Deep Neural Networks. Displayed here is the public course website, and if you scroll down, you can find the tab entitled Programming Prerequisites. So programming is an essential part of the subject of deep learning, and therefore programming will be a significant part of this class. However, I do not want to make substantial programming background, substantial Python programming experience to be a prerequisite for this class. For this reason, I'm recording and uploading this tutorial video to serve as a quick introduction to the necessary Python concepts that we will be utilizing in our class. The Python concepts that we'll cover are not that advanced, so they include variables, loops, functions, classes, object inheritance, exceptions, Python lists, tuples, decorators, generators, NumPy library, matplotlib library, and some aspects of the PyTorch library. Many of you may have already seen these concepts in a different class, perhaps in a different language, in which case this video will serve as a quick introduction to the Python-specific syntax features. Some of you may have not seen these concepts at all, in which case this video hopefully will serve as a quick introduction to these concepts. And some of you may be quite familiar with all of these concepts, and in particular their instantiation in the Python programming language. And in that case, then there's no need to spend time with this tutorial video. Programming in deep learning. So I said that programming is an essential part of deep learning, but programming in deep learning tends to be relatively simple, provided that one utilizes frameworks such as PyTorch. So PyTorch is a deep learning programming, a Python programming library. And to build a library such as PyTorch is a significant and impressive computer engineering challenge. And doing so does require quite sophisticated and difficult programming. But our position is that we will be utilizing the PyTorch framework, and when we do that, then the programming that we end up doing, and more broadly, a programming that a deep learning scientist would do day to day, tends to be relatively simple. It involves defining variables, defining classes, instantiating classes, and executing for loops. So in deep learning, it is the deep learning that is the hard part. The programming tends to be relatively simple. The design objective of a framework such as PyTorch is to allow deep learning to be executed with a few lines of simple code. To achieve this design objective, however, these frameworks do utilize some advanced programming concepts such as inheritance, decorators, and generators. But the way they are utilized is they're utilized in a very user-friendly way, such that it is helpful if one has a rough understanding of these concepts, but having a solid mastery of these concepts is not necessary. So through this tutorial video, I want you to become roughly familiar with these concepts, but you don't feel the pressure, the necessity to have a firm mastery of these concepts, because that is not necessary. In particular, I do not expect the Python programming that you need to do in this class to be a major challenge of this course. Okay then, let's get into the tutorial. The first step of the tutorial is to install the necessary software. So first, you'll need to install the Jupyter Notebook and Anaconda. So what you will do is you'll go to google.com and search Anaconda install. So when I search Anaconda install, there is a link for the Anaconda installation. I click it, and then it tells me that if I want to install Anaconda on whatever operating system, so this is a Windows machine, so I'll be clicking this link. It tells me to go here, and then I can download this installer, and once the download is complete, I can click on it to perform the installation. Of course, I have already done the installation, so I will cancel this download and I won't go through with the installation, but this should be relatively straightforward. Now, once you install Anaconda, you will want to, on top of Anaconda, install certain libraries. In particular, you will want to install PyTorch. So let me show you how to install PyTorch. So I'll go to Google and I'll search install PyTorch. Okay, so I'll go to PyTorch. And interestingly, if you go to PyTorch, you'll select the stable version. There's no need to select this. You'll select your operating system. I'm going to select Windows. And then you've already installed Conda, which is the Anaconda. I'm not quite sure why there is the name inconsistency. Sometimes it's called Conda, sometimes it's called Anaconda, in which case you've already installed Conda. And then we'll be using the language Python. And then if your computer is equipped with an NVIDIA GPU, then you may want to select these CUDA options in order to utilize GPU programming. So GPU computing is something we'll talk about later, but if you have the NVIDIA GPUs, you can select these things. But otherwise, if you don't, then you can just select CPU. And then finally, it tells you that this is the thing you need to do. So when we were installing the Anaconda software, and for that matter, when you install pretty much any program on your Windows machine, you download an executable file, a .exe file, and you double-click it to perform the installation. But when it comes to PyTorch, it's telling us to use this command to perform the installation. So what this is saying is that once we've installed Anaconda, we can execute what's called the Anaconda prompt. Let me make this bigger. So we can install this Anaconda prompt, and on this command line, we can execute these types of commands. So I will copy this text, this command, and I'll paste it here with Control V, and that will start the installation. That will start the installation. Of PyTorch and Torch Vision with the CPU only option. Now I pressed Control C to interrupt this installation because I have already installed PyTorch on this system. But if you were to proceed, if you were to let this run, then it would, on your machine, then it would go through the PyTorch installation. So once you've installed Anaconda and then once you've installed PyTorch on top of Anaconda, then you're now ready to work through the Python tutorial together with me. On the desktop, I've downloaded this tutorial file, which you will be able to find on ETL. To execute this file, I'm not able to double-click and execute this file. So instead, what I will do is I'll execute the Jupyter Notebook. So this command line thing is going to appear. That's natural, so just minimize this thing. Now the Jupyter Notebook has been executed. It doesn't yet have a file open, so I'll go to the desktop location, and I'll click on the Python Notebook with the extension IPyNB. So this thing was initially called the Jupyter Notebook, but later it was initially called an IPython Notebook. It was later renamed to the Jupyter Notebook, but that's why the extension is called is still IPyNotebook. Okay, so the IPyNotebook is structured in this way. So there's a bunch of text. This is text that I wrote, and there is blocks of code that can be executed in line. So the Jupyter Notebook is a very effective tool when you want to present code and accompanying explanation. Let's start with the tutorial. So first we have the Python basics. So this part, this is text. This part is code. So if I can execute this by pressing Control Enter. It prints something. I'll explain this output in a minute. And for a lot of the content, I'll be also providing some reading that you may want to do to get a more detailed understanding of the things that I talk about. Okay, so in Python, there are variables. But in Python, unlike, let's say, a language like C++ or Java, the type of a variable will be inferred by the language. So, for example, if we say x is equal to 2, then through this command, if we just have this, x is equal to 2, this performs an action, but it doesn't provide an output. 2 is a variable of type int, and x is a reference variable referring to the int with value 2. And when we define a variable, we can check the type of the variable with the type operator. So we can do print type. This will print out the fact that this variable is of type int. So this type operator, it displays a variable type, and it is So, the type operator is useful for understanding the details of the code and also in debugging code for looking for errors in your code. An int variable type is a variable with assigned integer values. So it can take value 0, it can take value 1, it can be -1, it can be 100, -100. It can take integer values. Okay, so that's the variable of type int. And then we have a variable of type float. So the variable type float in Python is used to represent a number with, roughly speaking, 16 digits of precision. Now I do want to clarify that the float is a float in Python is what would be referred to as a double in other programming language. So in C++, for example, a C++ has a float data type and a double data type. A float is represented with 32 bits, double is represented with 64 bits, and it has higher precision, 16 digits of precision. But in Python, there's just the float, and every float is represented with 64 bits. Python does not natively support a single precision floating point number. So a Python float is equivalent to a double in Java or C++. Okay, so here, if we set y is equal to 2.0, then that makes the variable y a variable of type float, or it makes 2.0 a variable of type float, and then y is a reference variable referring to this 2.0 object. If we were to remove the 0 and just write 2, then Python would infer this object to be of type int. But if we write if we have the decimal place in there, it signals to Python that this is to be understood as not as an integer but as a real number. In Python, there's the variable type str. So str is short for string, and it is a sequence of 2 or more characters. When you want to specify a string, you enclose the string within a pair of single quotes or double quotes. So here, hello world, that's the string. So the content of the string is what's within the parentheses, and so on the right-hand side, we have a variable of type str. And a is a reference variable referring to this string. And if we print out the type, it prints str. If we print a, then it will print out the contents of the string. A string can be enclosed with single quotes or double quotes. So if we replace the single quotes with double quotes, everything will remain the same. Now let's go through this exercise. So let's try this. So print McDonald's. Now, okay, so this is just a string containing the characters McDonald's, but what's noteworthy here is that this string is enclosed in double quotes, but there is this thing used as the apostrophe. But the apostrophe is the name that we give for the grammatical thing in English, but from a computer character perspective, this is the same character as just the regular single quote. So if we were to try to enclose this string with single quotes, then it would not work, because if we do this, then the Python doesn't know that this is meant as an apostrophe. All it sees is just a single quote character. So it will consider this first thing, McDonald, as the content of the string, and then Python becomes confused as what this S prime thing is. So the reason you want to have the reason both single quotes and double quotes are allowed in the construction of strings in Python is that if you want to use single quotes within a single quote within a string, then you enclose the whole thing with double quotes. Conversely, if you have something like if you want to write a quote within a string, then you can do something like this. So Andy sang the song, Old MacDonald had a farm. He was a good singer. So here, the entire string is enclosed in single quotes, and double quotes is used as just the current grammatical thing. It's used as a quote, and it's not used in order to delimit a string. Again, if I were to try to use single quotes for in this case, then things wouldn't work because Python would view this as one string. This would just confuse Python, and then this would be another second string. Okay, now let's take a look at a few more of these examples. So if you look at just this cell as is, by the way, this cell is a markdown cell. So a markdown cell is a cell in Jupyter Notebook that is meant to contain text to be read by humans. A code cell is a cell that is meant to contain Python code. So this is a markdown cell, but if you double click the cell, that you can see exactly how it is that I wrote this cell out. If you copy and paste this first item and execute it, then it prints out McDonald's. But if you copy and paste the second line, then it also prints McDonald's, the same exact thing. But note that there's this extra thing here. So this extra thing, that's the Korean won symbol. But on a Korean operating system, the won symbol replaces the backslash symbol. So if you are to open up this file, execute this Jupyter Notebook on, let's say, a US Windows system, then this character would instead be rendered with this backslash symbol, but on a Korean operating system, it's replaced with the won symbol. In any case, this is the won symbol. This is the backslash. I'll be referring to this as the backslash symbol. So backslash single quote is used to signal that this character is to be understood as a single quote rather than as single quote character rather than a single quote that is used in the Python language to delimit the start and end of a string. So in this case, because we are enclosing the string with double quotes, this backslash symbol doesn't make any difference, but it does in this following example. In this example, we're enclosing the string with single quotes, but because we're using the backslash symbol, we are able to use the single quote within our string. If we were to remove this, then it doesn't work because now this single quote is getting matched with this single quote, and it just doesn't work. So by using the backslash symbol, we are able to typeset single quotes and double quotes and other sort of characters in a string. And for example, if we have a long string that contains both single quote, double quotes, and apostrophes in the English language, then it would be necessary to use this backslash symbol in order to make things work. But you might wonder, what if I want to just print the backslash symbol as is? Maybe I just want to print this as is. Well, if that's the case, you can use the character R, which you can prepend the character R at the beginning before the string, and this means the string is to be read as what's called a raw string. So just read the string as is without any processing of the backslash symbol. Here we have three times a string. So 3 times in this case means we are to repeat this string 3 times. Here we can add 2 strings. So adding to string is this is concatenating strings. So plus means concatenation, and we are adding McDonald and apostrophe s. If we don't have the addition, then this is we can perform concatenation also without the plus symbol, so we can just write the strings sequentially. And then finally, if we want to have a multi-line string, then we can use these triple quotes. So the triple quotes with double quotes or with single quotes, the quote character repeated 3 times is used to write a multi-line string. Okay, now let's move on. So especially in this class, we will be indexing things all the time. So an index is a number that is assigned to locate particular objects or particular components within a string, an array, a matrix, a tensor, and so on and so forth. And the convention in Python is that at least to begin with, let's start about indices for strings. So indices for strings in Python refer to positions between characters. So let's say we have a string with P, Y, T, H, O, N. So there are 6 characters within the string. Then position 0 is the position before the character P. And then position 6 is the character after N. Position 3 is the character between T and H. And Python also uses negative indices, which is actually quite convenient. So index 0 is before the character P, but -1 it then becomes the position right before the last character. -2 becomes right over here, and then -6 in this case is equal to 0. So if you have a string named sequence, or let's say a list or a tuple, some sort of sequence thing, if you want to access a single element immediately after the index, then use sequence index. So for example, let's say s is equal to Python. And then if we do print s0, then what this means is position 0 is right here. But accessing s0, that means let's print the character immediately after the index. If we print s comma 2, s at 2, then this is position 2. Well, t is immediately after that. If we print position 5, that's the last character. If we print position 6, then, well, that's out of bounds. Position 7, that's also out of bounds. Let's try position -1. So -1 is right over here. So -1 prints the last character n, and -6 prints the first character p. Now in Python, you can access more than one element within your sequence or your list, your string, using what's called the slice notation. So the slice notation specifies 2 index positions separated by a colon to access a subsequence. A sequence start colon stop that returns the elements within the sequence between the start and stop. So remember we said that indices refer to positions between characters. Well, this perspective becomes useful when most useful when you reason with the slice notation. So if we are to print s2 colon 4 in this case, well, 2 is right here, 4 is right here. The 2 characters between 2 and 4, that's T and H. And indeed, that's what we get. Now, in the slice notation, if we omit the start or the stop, then it's defaulted automatically to be the beginning or the end. So if we do just colon 4, then, well, this position is the starting position is unspecified, so it's defaulted to be 4. So the characters between 0 and 4, those are these 4 characters. Okay, and if we do 2 colon nothing, well, between 2 and the last character 6, the last position, the last index 6, we have these 4 characters. And if we do just nothing colon nothing, well, then we just have from the beginning to end, this is the whole thing. So the basic form of the slice notation is that you have a colon and you specify the start and stop positions, but you can be a little bit more fancy. So you can have 2 colons in your slice notation, and you can provide the start, the stop, and then the step size in the slice notation. So this returns elements within the sequence between start and stop, separated by step, and step is by default set to be equal to 1. So if we set s is equal to Python, then set colon colon 2, this means between 0 and last is 6 with the step size 2. So 0 from 6 to 1, that prints out everything. From 0 to 6 to 2, that prints out the 0th, the second, and the fourth one, the fourth positions. Okay, and then likewise, we can print elements in the odd numbered positions. And the way we do that is that instead of starting from position 0, we start from index equals to 1. So that way everything is shifted right to by index of 1, and that prints out all the odd positioned characters. And then if we want to print characters in the reverse order, we can go from start to end, the whole thing, but with a step of -1. Okay, so this prints the Python in the reverse order. And then if we want to do reverse indexing with a subsequence, we can do that, although, so this is possible, but now it gets a little bit confusing. But it is, I just let you know that reverse stepping with a subsequence is indeed possible. When you're programming, properly and adequately commenting your code is essential. So here's how you write comments in Python. And the reason commenting is essential is because a code that is undocumented, that is uncommented, is maybe understandable to you at the moment, but it becomes not less understandable over time by your future self, and also it's less understandable by your colleagues. So writing code that is well commented is essential for productivity and for accuracy. And so you want to make commenting a habit. And a wise man once said, "We first make our habits, then the habits make us." So in order to become a good programmer, you really do want to, as you code, you really do want to put some thought into how you want to comment your code so that you can communicate your ideas, the structure of your code, to your colleagues and your future self more effectively. Python has two types of comments. So one is the multi-line comment, and there are the short inline comments. So this symbol, which is on a computer written by pressing the button Shift 3, has many names. So this name is in the programming community referred to as the hash symbol, and for this reason, this symbol was when it was used by Twitter and other SNS services to tag photos and tag other content, it was referred to as the hash tag. It's the hash symbol used to tag something, hence the name hashtag. But the thing is, the symbol itself is not the hashtag. It's only referred to as the hashtag within the SNS services. More broadly, in the programming community, it's referred to as the hash symbol. But even more broadly, in general society, this is not referred to as the hash symbol. It's referred to as the pound symbol. So if you go to the United States or let's say the UK and ask a grandmother what is this symbol, they would recognize this symbol from their old telephone, and they would refer to this as the pound symbol. In any case, we are in the programming context, so I'll be referring to this as the hash symbol. So the purpose of the hash character is that anything that comes after the hash symbol on the line is ignored, and therefore therefore it allows us to write a human readable text in the as the ignored content. So okay, so here this is saying this is a single line comment, and this text is clearly written to be read by a human. It's not read to be read by but parsed by the Python interpreter. So here, this print before comment, this is code that is to be executed by the Python interpreter, and it will produce a demonstrable result in the when we execute the code. Now here we have another single line comment using the hash symbol, and this is English text written to be read by humans. And then we have a multi-line comment. So a multi-line comment in Python is written just with multi-line strings. So it's delimited by a pair of triple quotes, either with double or single or double triple quotes. And this is just this is a multi-line comment, and it's just a string because remember, a multi-line string is written in exactly the same way. So this is just a multi-line string sitting within the code that otherwise has no use. So a multi-line comment is written with a multi-line string in Python, and so therefore the effect of this is this creates a string, but this string is not used in the program. So effectively, this serves as a piece of text that's not utilized by the Python interpreter. So the next topic is Python lists. A list is an ordered sequence of 0 or more comma delimited elements enclosed with square brackets. here is an example. So this whole thing is delimited with, it's enclosed with square brackets, and the 8 elements, the 8 int objects within this list, they are delimited, they are separated by the comma character. So if we print out the whole list, we get 1, 2, 3, 4, 5, 6, 7, 8. This is another way to print out the whole list, but we can also do something like this to get a subset of the list. So from we get from 2:5, that means we get these numbers. If you have two lists, you can concatenate them with the plus symbol. So here s is equal to the concatenation of these two lists. So we do print s, and we get all characters A, B, C, D, F, G. Note that in Python, a list can have heterogeneous types, meaning it can have the things contained in the list can be different. So here we have the string contains a length 1 string, a bunch of length 1 strings, and it also contains some integers. It can contain a float. The variable types within the string can be different. So here, if we look at this exercise, if we print, let's say, s colon -2, we get all the elements up to position -2. So I urge you to try out all these things. But let's try this thing. So what this does is it takes the 0th element of the list and changes it to z. And we don't have to change it to the same type of thing. We can even change it to anything else, and the list gets modified. Now we also used the slice notation with strings before. So let's say if we have a string that looks like this, and if we try to modify the character of a string, this is not allowed. So even though we are using the same the indexing and slice notation when we compare strings and lists, there is some difference in behavior. When it comes to strings, you're not allowed to modify individual characters, whereas with lists, we are able to modify individual characters. We are also individual elements. We are also able to modify a bunch of characters, a set of characters using the slice notation. So this tells us that, let's first execute this. So we are also, when it comes to lists, we are also able to modify a set of elements. So here we're using the slice notation to access the first 3 elements of the list. And if we do this, then this takes this list and it modifies the first 3 elements to be this. Okay. Lists can also have lists as their element. So here within a list, this list K has 3 elements. It has the 0th element, the first element, and the second element. And then the 0th element of this list has 2 elements. It has the 0th element and the first element. So if we print this out, this should print out value 2. This should print out value 1, and this should print out out of index out of bounds error. And we can do things like this. Okay, next we have the range function. So the range function is used all the time in the construction of for loops, and we'll take a look at that soon. The range function generates a sequence of numbers into a list, and the endpoint is excluded. So let's take a look at this example. List range 0, that contains a list that generates a list between 0 to 9. So 0 starts from 0, and the endpoint 10 is excluded. We can also provide a starting point. So here the starting point is 1. We go up to 10, but 10 excluded. In the output, 1, the starting point is included. The endpoint 10 is excluded. We can also specify a step, as we did in the slice notation with the range function. So here we start at 21, we step by -2, and then we go up to -1 with -1 excluded. So the list contains 21, 19, and we're decreasing by value 2. We go up to 1, but the endpoint -1 is excluded. Now here, note that in this command we have print list range. So the range function again is used all the time in the construction of for loops, but if we just print range without calling the list thing, it's going to say range 0, 1. And so that's because the output of range is not actually a list itself, but rather it's an iterable object. So that distinction is not some, well, I don't want to dwell on that distinction for the moment. We will discuss this issue more later when we talk about iterables and generators. But for the moment, just understand that if you want to print out explicitly the content of that the range function outputs, you need to explicitly convert that into a list with the list function. This way, you can explicitly see the entire content of this of the range when you print it out. Okay. Next, let's talk about the if-else statement. So you can write if-else statements in Python in this way. So you write if and then specify a condition. And when you specify a condition, there's no need to write it within parentheses. Although here I use this angled bracket thing. And then you end your if statement condition with a colon, and then you write the if statement body with just code. But note that there's an indentation here. And then if you have other else conditions, you write, instead of writing else, you write elif. So this is to be read as else if, and then else. And then whatever comes after the if-else statement comes after. So let's take a look. First, let's just look at this version. So, and then let's execute this. Let's execute this code. So here, x is -4, and then the condition is that if x is positive, then we will be printing x is positive. Well, let's make it positive. In this case, this condition evaluates to be true. So the if block body executes, and this code executes. Whether x is positive or not, this code it does not go inside of the if-else statement, so it executes all the time. Now, in a language like C++ or Java, you might be familiar with something like this, where you have curly braces to denote the beginning and the end of the if statement body. But in Python, that's not the case. So in Python, what happens is in Python, the way you indent your code actually has meaning in terms of the code. So in a language like C++, you use white space to separate things, but the way you break lines, the way you add space in addition to just having space in between things, does not affect the meaning of the code. It affects how humans would perceive the code. It affects how understandable the code is. But from the C++ compiler's perspective, the compiler doesn't care about whether you have a white space or not. That's not the case in Python. So here, the indentation explicitly means that the indented content belongs within the if block body. So for example, here, this more stuff, more print. The second print statement is part of the if statement body. Now, if I change the x value so that the if statement if body doesn't execute, then this line did not print. But if I remove the indentation, then it does print. So whether this line of code belongs to the if statement block or not depends on the indentation. So if you want to include it, you should indent it properly. Now here, if x is negative, we have this else if block, and then we have finally the else block. So when we have an if else if else construction, we have sort of these exclusive cases. So only one of these bodies will execute, and in this case, that is indeed true. So in this case, x is negative, so this else if body was executed. If x is 0, then this part will execute. Okay, next we have the while loop. So the while loop is constructed by writing while and then condition, and then we have a colon here, and then we have an indentation here. Again, the indentation matters, and then we have these things within while loop. Okay, so let's give this a try. So here we just say var variable is equal to something, and while the thing and then while the variable is not equal to goodbye, we type in something. So here we're using the input command to get something from the command line. So I'll just say hello, and then it says you entered hello, and then the while loop will continue on forever. So so this will continue forever until I say goodbye, and when that happens, then this condition will evaluate to be false, and then we will exit the while loop body. Again, indentation is not optional, so if I were to indent nothing, then something's wrong, because here we have a while loop construction, and following this while loop construction, there needs to be something that corresponds to the while loop body, but right now nothing's indented, so nothing gets attached to the while loop body. So in Python, pay attention to how you indent things, but because it really does affect the behavior of the code. Next, we have a for loop. So the okay, let's exit. Okay, so next we have a for loop. So the way you write for loop is, and this is different actually from how you would do things in C++. So pay attention. So we write for a variable within a list. So there's code in a loop and then code after a loop. Again, indentation is not optional. All right, so let's do that again. So let's go through an example. So in this example, we'll print the Fibonacci sequence. So the previous value is 0, the current value is 1, and then we'll do this for loop, and then we'll just do this Fibonacci sequence calculation, and we'll print out something once at a time. This is the first 10 elements of the Fibonacci sequence. Now, what I want you to pay attention to is, well, this part is part of the for loop body, and at this point we are familiar with this. But here, this is how you construct a for loop. So there's a variable within a list. So remember, range returns a list, or actually something like a list. It's actually an iterable object. In any case, so in C++, you might write something like for int I equals 0, I less than 10, I plus plus. You would write something like this in C++ and in Java, but this is not how you do it in Python. In Java, you would have something like an enhanced for loop, a for each loop, and that's something more similar to what we have here. So to execute a for loop, we don't have a for loop index explicitly in Python. Rather, what we do have is we provide a list of elements, and we will be processing those list elements one at a time. If you just want to have a for loop with a numerical index I ranging from 0 up to, let's say, 10, then you can accomplish that by creating the list with the range function. So the reason this is this type of enhanced for loop, or this is also referred to as a for each loop, the reason this type of for each loop is useful is because sometimes you might have things that are elements that you want to loop over that are not numerical values. So here we have a list of fruits, and if we were to do this, well, for all x in fruits, we print out the thing, or all, perhaps this would be fruit list. This would be a better style. So for all fruits in the fruit list, we print them out one at a time. So here we had a list of 3 strings, and we were able to process all 3 strings without having to explicitly keep track of an index. So more generally, the for loop works with any iterable object. So a list is an iterable object. Actually, a range object is also an iterable object. But there are other things as well. So here is a string. A string is also an iterable object. So we can iterate through the characters one at a time. So for each character within this string, we can do something like this. So the current character is THE space, and we can go through all the characters one at a time with this type of for each loop construct. The next topic is list comprehension. So list comprehension is a very Pythonic way to construct lists. So the word Pythonic is a word used within the Python community. It doesn't exist within the dictionary, obviously, but it's a word that Python people use, and I like it, and I like the word. And the word Pythonic is used usually in a positive way to describe things that can be done utilizing a Python-specific syntax and things that are done so in an elegant way. Okay, so let's take a look at this list. All right, so this list, it says I square. So here, this is the power symbol. So we're taking I and raising it to the power of 2. So we're taking I squared. So I squared for I in range from 0 up to 5. Okay, so the result is 0, 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. Now the thing is, so the way to interpret this type of list comprehension is you should view this as something similar to a for loop. So we are creating, for all I within this iterable range, so from 0 to 5, we take all of those i's, and then we perform this computation, and then we form a list with that. So there are 5 i's within this list. There are 6 i's within this list, and then we perform this computation to form the list. So if we could do something like this differently, so perhaps 2 times I, that would give us something like this, or 2i plus 7, that would give us something like this. So any kind of numerical computation we can, or any expression we can put in here. Sometimes we might not need to use the variable to keep track of the elements within our list. So here's an example of why that would be useful. If we want to have a list containing 5 zeros, then we can just use list comprehension. So for 0 with this thing within the range of 5. So you can use the index I here, but then the index I is not used. So when you want to avoid perhaps symbol conflicts, and also if you want to signal to the reader of this code that this variable is not going to be used, then you can just use this underscore symbol as the name of the variable and just not use it. When you're using list comprehension, you can also use if conditionals to filter out elements. So we want to, in this case, construct the list of I square, but we want to keep only the even elements. So we do this for I within 0 to range, and then if I is even, then we perform this computation. So this filters out the possible i's that will be used in this computation, and we get this. So 1 squared, 3 squared, and 5 squared, that's not included in this list comprehension. We can also use multiple for clauses within the construction of a list comprehension. So we do list of I plus j. Well, we can do for I within range 2 and j within 0 to 3. So we get all of these combinations. And then we can also do this. We can, swap the order, right? So for j in range 4 and I in range 2, the whole thing is this, the contents of the list are the same, but with the order changed. So this distinction is not something I urge you to spend too much time on. It's not that important, but if you want to understand the meaning of these orders, you can think of this list comprehension as an equivalent to this for loop. So for I, for j, that's like the for I and the for j as a nested for loop. Okay, Okay, and we can also have a nested list comprehension. So this is a list comprehension with the variable I with j fixed, and then within the outer list comprehension we have the variable j. So this is the result, and then also, well, this is the result if we swap the order of I and j. So as just a fun exercise, you can try to think about how to construct a list comprehension to create this particular list, and also for this particular list. Okay, our next topic is the mutability of strings. So strings and lists share a lot of commonalities. So a string is a sequence of characters. A list is a sequence of things, where those things don't necessarily have to be of the same type. A single character of a string can be accessed with the bracket notation, and the same can be done to access a single element of a list. You can use the bracket notation. To access multiple elements of a string or a list, you can use the slice notation. So those are the commonalities, but there is one key distinction between these two objects, and that is their mutability properties. So strings are immutable. In other words, they cannot be modified. There does exist some methods that seem to modify a given string, but what's actually happening with those methods is that instead of the string itself being modified, the seemingly modifying method is returning a modified copy of the original string. The original string is kept unchanged. In contrast, lists are indeed mutable, and so they can be modified. The elements can be added to a list, elements can be removed to a list. So here are a few examples of that in action. Let's take a look. Okay, so here we have list 1 is equal to 1, 2, 3, 5, 1, and then list 2 is equal to list 1. Now, in addition to demonstrating that lists are immutable, I also want to make the point that, and this is a point that I'll revisit soon, that there's only one list throughout this code, and that's this list. There are two reference variables referring to the same list. So list 1 and list 2 are reference variables. They are like pointers in C++, if you will, and they have two names. One is named list 1, the other is named list 2, but they are referring to this single same list object. So when we print out the list using the reference variable list1 or list2, the name that we use doesn't really matter because we are referring to the same list, so the output should be the same. So here's a method that modifies a given list. So here we remove 1. This means we are removing only the first occurrence of the number 1 within our list, list number 1. And when we do so, when we execute this command, the output is the modified list. So the number 1 has been removed from this list, and we can actually observe that modification whether we access the list through list 1 or list 2, because again, these names, we have two distinct names, but there's only one list object that these two distinct names are referring to. Next, here's another method. So this method is pops the element in position 2. So at this point, since the initial number 1 has been removed, this is position 0, this is position 1, this is position 2. So the number 5 is removed from the list by calling this pop method, and we can observe that change by reading the list through the reference variable list 1. But if we were to change this to list 2, it would be exactly the same because, well, the two names, they are referring to the same list object. Okay. There's the method append that we can use to add things to the end of the list. So when we do this, well, the number 6 is added to the end of the list. And then we can also insert things to the list. So we'll be inserting 7 to position 0 of the list. So the list used to be 2, 3, 1, 6. Now number 7 is inserted to this position. We can, of course, insert this number to other positions as well. We can also sort our list. So this will sort our numbers list in ascending order. So from smaller to bigger, that's the way this is being sorted. And then we can also, given the list, we can reverse the ordering. So the list used to be in this particular order. Now when we reverse it, it's going to be reversed front to back. And again, just to reiterate this point, there's only one list throughout in this program, and that's this list. This list gets modified multiple times, but in any case, it's this one list that is being referred to by list 1 and list 2, these two reference variables. So in the end, when we print out the result with list 1 or list 2, the result is the same because, again, these two variables are referring to the same single list. When you want to make a copy of a list, you can use a method that's named copy, but usually the most concise way and the most commonly used approach is to use the slice notation. So the slice notation in general creates a copy of a subset of the list. So the slice notation is usually used to access a subset of the elements of the list, and when you do so, another list gets created. But if you use the slice notation without specifying the beginning and the end, you're accessing all elements, and when you do so, you get a copy. So this notation, where you just read all elements, is the purpose of this is to create a copy. And then now that we have two distinct lists, so when we take the copy, let's just first execute the first 4 lines. When we execute this, this is 1, 2, 3, 5, 1. That's our list 1, and the list 2 is initially made to be a copy of list 1. So now in this program, there are two distinct lists, and list 1 and list 2 are referring to those two distinct lists. At this point, the two lists contain the same content. So these are two separate lists, but they contain the same content. So when we print it out, the result is the same. But if we now modify list number 1, list number 1, when we modify list number 1, that affects our first list, but it does not affect list number 2 because now list 2 no longer refers to the same list. It refers to a copy of list number 1. Okay, so we talked about lists as a basic Python data structure. Next, let's talk about dictionaries. So a dictionary is a set of keys, each point mapping to a value. So the keys must be unique, but the values can be repeated. And if you know a little bit about data structures, this would be implemented with something like a hash table. And in the C++ language, in the C++ standard template library, the map class template offers a similar functionality. And in Java, the interface map and the implementation of the interface hash map offers a similar functionality. So here's an example. We create a dictionary containing people's names and their GPAs. So the person is named Alice and her GPA is 4.23. This person is named Bob, his GPA is 4.1. Charlie's GPA is 3.8. Daniel's GPA is 3.8. And when we create this dictionary, the Python notation syntax is that we use these curly braces to create dictionaries. Remember, so the brackets is used for lists, and then curly brace is for dictionary, and we will soon see that parentheses are for tuples. Right, so bracket is for list, we saw this, dictionary, that's curly braces, and parentheses that will be used for tuples, which we'll talk about soon. And when you specify, so within curly braces, you specify elements, entries to the dictionary, and each entry of a dictionary should be a key value pair separated by a colon. So for this first entry, the key is Alice, and the entry is, the value is the float 4.23. So this number is as an object is of type float in Python. The key for this second entry is the string of Bob, and the value is the float with value 4.1. And you get the point, so the key is Charlie, the value is 3.8, the key is Daniel, and then the key and value separated by colon, and the value is 3.8. So once we define this type of dictionary, so D is now defined as a dictionary, we can do something like print D. So we can print out the entire dictionary, that's also possible, but when you have a dictionary, you want to access the elements, the entries of the dictionary one at a time, and the way you do so is you provide the key. So if you provide the key Alice, then we retrieve the value associated with the key. Now if we, let's say, try to access a key that doesn't exist, well, then it's going to say there's an error, the key Ethan doesn't exist, but if we provide a key that does indeed exist, then, well, we get this. Now we can also print out the list of, print out all the keys. So, so if we do d.keys, then we get, well, all the keys within the dictionary. And we can also print out all the values, and, well, these are all the values. Now, if you think about this use case, then I think it's pretty clear that the keys should not overlap. The keys should all be unique, whereas the values can be repeated because each value is associated with the key, and there's no a priori requirement that the values must be distinct. And in this particular example, it's quite clear that the GPAs of different people, there's no reason for the GPA to not repeat. But if I were to, let's say, try to have another Daniel, and this could happen in real life, right? Because there may be multiple people that with the name Daniel, so you might have a dictionary that what looks like this. Well, this the problem is if you do this, then it doesn't print out an error, but the behavior is not what we expect. So there's only one entry with the key Daniel. So when we provide multiple values to it, the second entry overwrites the first entry. So in real life, if you were to have multiple people with the same name, then you should have some uniquely identifying let's say a student ID number associated with each individual so that this type of key conflict doesn't happen. Okay, next let's talk about modules in Python. So modules are packages and classes, or packages with classes and functions, and the way you access them is you import them. Okay, so this is something you'll do quite often. You import the module random. So the module random is not something that you have to separately download. It's not something that you have to write. It's something that's provided to you by the Python language. And the module random contains things related to random numbers and random number generation, as the name would suggest. So if I don't do this, if I just execute this code, then it's not going to work because, well, if I try to call the function named random, I never defined a function named random. All of these features that I'm trying to use, they have not been defined by myself, so Python doesn't know where to locate these features. But instead, if I import the module random, then I can access the functionality provided by this module. So within this module named random, there is a function named random that it returns a uniform random number between 0 and 1. There's also a function named randint, and then there's a random shuffle feature, so it will take in as input a list, and it will shuffle it. And there's also a function named sample, so it will sample 2 elements from our given list with a uniform probability. So these are some features provided by the module random. But sometimes the name of a module might be too long, inconveniently long. So the name random is a very good name for a module because it tells us immediately what the purpose of this module is. It gives us an idea of what the functionality provided by this module is. But it's 6 characters, so it's not too long, but it might be more convenient for us to be able to abbreviate it. So if you want to use a particular module quite often, then it's helpful to specify a more shorter name. In this case, it's common to import the module random as rnd. So once you do this, then we are able to now access the contents of this module using the abbreviated name as rnd as opposed to its full name random. Of course, it's possible to have a very long name when you import it, but then there's no reason there. Why would you do this, right? So usually you use this use the import as clause in order to provide a more abbreviated, shortened name associated with the module. However, sometimes importing a particular module with an abbreviated name and using the abbreviated name to access the contents of the module might even be a bit cumbersome. So what you can do is you can just import everything from a module, and once you just import everything from the module in this way, you are able to access its content without referring to the name of the module. So here we do from import star, from math import star. So now that we've done this, we are able to just refer to random the function random as random. There's no need to say. We used to have to say random.random, or we had to say rnd.random, but we can now just say random, and Python will now know that this function is imported from the module random. Now, this is done quite often. From module import star, this is done quite often, but in my opinion, this is bad programming practice because once we do this, we completely lose track of where a given function comes from. And more importantly, there is a risk of name conflicts. So, for example, here, if we do print random, okay, well, random, you can probably guess that it comes from the module random, but like, what does log5 mean? Because the word log could be referring to the logarithm, the mathematical function logarithm, and you might want to compute the log of 5. That's, well, maybe that's your intended meaning, but it might also mean that the word log means to keep track of, right? So maybe there you have a functionality that you designed for debugging purposes, and you want to keep track of a certain activity, and you want to, let's say, write down or keep a record of some activity that happened, and you want to record the value 5. How do you know which function that corresponds to? And it's not that clear in this context. So this is a hypothetical and somewhat contrived example, but this type of name conflicts happen all the time. And in this code, it really would be much more clean and much more obvious if you write math.log. Yes, math.log is longer than just writing log, but now the meaning is much more clear. Yes, log, now it really has to be the mathematical function for computing the logarithm. So doing this blanket import with from module import star is done a lot. If you look at code that other people have written, especially online, you will see this all the time. But nevertheless, I do not recommend this as a general practice. I don't want you to get in the habit of doing this. So in order to remove all the bad imports, this is some naughty behavior that I want to cleanse myself from. I'll execute the reset command so that now the imports are gone. And now let me do things more properly. So if there is a specific functionality from a module that you use very often, then what you can do is, instead of doing a blanket import, you can selectively import that particular feature name. In this case, it's a function. So here I'm importing NumPy, the module, as with the abbreviated name NP. So, and using the NumPy, using the functionality of the NumPy module. In particular, I'm using the class constructor for the class matrix. In any case, I'm creating a NumPy matrix with this command. And then I could be, in order to compute the eigenvalues, I could be doing this. So numpy.linearalgebra linalg.eigenvalues of A. So np.linalg, that is a submodule of the, so np is numpy, right? So this is numpy.linearalgebra. So this is a submodule within the module numpy, and there's a function named eigenvalues within that module. But that's all just a little, that's too long. So this whole thing is a little bit too long, but what we can instead do is we can, from the module numpy.linalg, we can import the function eigenvalues. Now, once we do this, then we can just refer to the function by its name without specifying where it came from. And now Python understands that the function eigenvalues is provided by the module numpy.ling.alg. So this approach of more selectively importing common functions that you'll be using repeatedly is much more safer, it's better style, and it's the approach that I recommend compared to doing this blanket import. So again, to reiterate, I believe I view this from module import start blanket import to be of bad style, but I'm letting you know about it because this is used quite a lot, so you will inevitably encounter code that utilizes this feature, and I tell you about this so that you don't use it. Okay, next let's talk about variables. So we have already been using variables throughout this tutorial, but let's have a more in-depth discussion of how variables work in Python. So in Python, variables are names that refer to things. So when I say use the word things, it's an informal word, but I'm referring what I mean by things is things like objects, functions, those kind of stuff. So variables are names that refer to things, but they are not the things themselves. Let me repeat, variables are names, and the names refer to the actual things, but they're not the things itself. Okay, and in Python, when you change something, there are sort of two notions of changing something. Here's and here are the two possible notions. Changing something means changing what the name refers to. So when you use the equal notation, you're assigning a reference variable to refer to something, and when you perform that again, you change something. A name once referred to something, it later is made to refer to something else. Another notion of change is that you can be mutating the thing that is being referred to, perhaps using a member function. Okay, so these are having a precise understanding of these distinctions is important, because if you don't, you need to have a precise distinction of these two notions. Otherwise, you will run into very mysterious bugs throughout your programming. So let's try to understand this better through some examples. Okay, so let's for the moment comment out these print stuff. Okay, so here we set x is equal to 5. And then f of x is a function that we've defined and we execute it. So we go into this function. The function is defined as f of x. We set x to be equal to 42, and then we print the thing. Okay, so those of you who have seen functions in programming before will not be surprised that the output here is 5, because whatever happens within this function shouldn't affect the outside world. And that is true, that's how Python is designed, but let's take a more closer look at what's actually going on. So here, the thing is, there are two things within this program. There is the int object with value 5, and there is another int object with value 42. And the name x, so x is a variable, and the variable is a name. So x is initially made to refer to this value 5, and we can check that, check the ID of what this is referring to. So let's take a look. If we execute this, right? So if we print x, the value of x is, of course, 5 at this point, but we can also probe the ID of this number, and the ID of this int object is this complicated thing. Now let's enter into the function call. So we enter into the function call, and initially x is passed in. So here we have another x. Now the ID of, if we print out the value here, the value of x is initially 5, because of course that value was passed into the function. But then after that, when we probe the ID is exactly the same. Why? Because this x is referring to the same object as this x. There is only one int object with value 5 in this program, and that int object has this ID, and at this point the variable x is referring to this int object. Now when we write x is equal to 42, what's happening is that we are not changing the int object. The int object is the initial int object had value 5, and it will forever have value 5. Actually, int objects are also immutable. So instead, what we're not changing, we're not mutating anything. Instead, we're changing what the name is referring to. So the variable x initially within this function f of x initially was referring to this object, but now instead we create another int object. We create the second int object with containing value 42, and we make x refer to that. And indeed, we can see that when we print x, we get value 42, but the ID associated, the ID of the object x is referring to is now different. The ID has changed because x is now referring to a different object. But the x inside the function is different from this x. So from the outside world, x is still in the outside world. The x variable the name is still referring to value 5. So we print out, we get the value 5, and we can verify that by checking the ID of the object x is referring to, and indeed the ID remains the same. So it is still referring to the same object. Okay. Now in contrast, so here there was, because the x variable, because int objects are immutable, there is no way for this function f of x to have an effect on the outside world when when an int object is passed in, because within this function the internal x can be made to refer to something else, but the immutable int cannot be modified, so there's no observable effect in the outside world. That's not true. That's not the case when we use lists, because, as discussed before, lists are indeed mutable. So let's take a look at this example. Here we have a list, and there is one list here. Okay, so list contains this character, the string of length 1 with a, and let's just for the moment print this. So let's also print the list at the same time. Okay. All right. So I should also mention this. So the name list in Python is reserved. So you should not name variables list. So say you should use something like LST. So here I'm naming my list LST because you can use the word a list, but the name list has other uses in Python, so it's not wise, it's imprudent to use a variable name list. So don't do this. If you want to just have a simple name for a list, use LST. Don't use the word list. Okay, so here we have LST is equal to a, and we print out the list. We print out its ID number, and then okay. So now let's call this function. So f of LST. Let's take a look at the function definition. So it prints out the list, and then it appends the number 5 to list, and then and prints out the list again. So within the function, initially it's passed in. Well, the list contains just this character a. And then the ID is the same because there's only one list in this program. And then we append the number 5 to this list. When we do so, the list becomes modified. The list has been mutated. And the ID of the list remains the same because we never created another second list. This is just the same exact list. And then this function terminates. But what we can see is that now this change that happened within the function f does affect the outside world, because there's only one list and the list is mutable, and the list was mutated within this function. So in this case, the change this line, this append operation changes the list, and the change that is happening here is not a change of what the name is referring to. It is mutating the thing that is being referred to. So LST refers to this list, and the function f takes in as input this list, and it changes that list. So the list that LSD is referring to, that became mutated, and that effect becomes observable in the outside. Okay, it's very important that you become completely familiar with these two distinct notions of changes. It's indeed a subtle issue, but it's central for you to be able to program in Python. Having this notion understood concretely is essential if you want to program in Python effectively without running into these very mysterious errors. Okay, so again, distinguishing a variable from the object itself is essential. So if we write something like this, x is equal to 1, 2, 3, this 1, 2, 3 is a syntax that creates a list object, and then the x equals means it enters the x into a symbol table. So the symbol table is a table of recognized names, and it makes the name x refer to this list object. Let's take a look at this code. So the x equals y represents is asking whether x and y represent the same thing, whereas the command x is y asks whether x and y refers to the same object. So let's look at the code. Okay, so we'll go through this line by line. So x is 1, 2, 3, y is 1, 2, 3, and z is equal to x. So there are two list objects in this program. There's one list object created. There is another list object created. The two list objects represent the same thing. They have essentially the same content, but they are not the same. They are not literally the same object. They are two distinct objects containing the same meaning. Whereas z, when we write z is equal to x, we are making this name z, this reference variable z, refer to this list object. So if we print x is y, this is actually false, because x and y are not the same. They do not refer to the same list object. But if we print x is equal to y, well, in this case, what this really means is we enter a for loop, and we check whether all the entries of the list are identical, and when that comes out to be true, this is true. So this is asking whether the two objects have the same meaning. In this case, it does, but it's not checking whether the two objects are the same, are literally the same object. Now, when we check x is z and x is equal to z, both of them come out to be true, because yes, z and x literally refer to the same object, and because we're asking whether an object is equal to itself, that is indeed true. And is y equal is z? Well, that's not true. Y and z are referring to two distinct objects, but y is indeed containing a list. It refers to a list that has the same meaning as the list referred to by z. Okay. Now, if we append an element to the list with to the list referred to by the reference variable z, we are appending the list number 4 to this list. So when we print x, we observe that change. When we print y, we don't observe that change because this second list has not been changed. And because z is referring to this same first list, when we print z, we get this. Okay, now let's reset to get rid of all the existing variables and take a look at this code. So using the keyword none in Python, a variable can be made to refer to nothing. So you might be familiar with something like this in C++ or in the language C. So a pointer can refer to null, and that feature can be utilized to have a pointer referring to nothing. In Python, the same can be done. So, but a variable referring to none is not the same thing as the variable not existing, because a variable can exist without referring to anything, right? So here, if I say x is equal to none, let's comment this out. When I say x is equal to none, well, the variable x now exists. There's nothing that x is referring to, but it does exist. So if we print x is none, yes, x is none. X is referring to nothing, so this comes out to be true. Now, after that, if I assign x is equal to 6 and print x is none, well, x now is referring to something. It is referring to the number, the int with value 6. So now it is no longer none. But if I try to print out this result, well, this is now an error because, and this is different from what we had before here, because here the variable x exists, so we are allowed to ask whether x is referring to something or nothing. But here the variable y does not exist, so it doesn't make sense for us to ask whether y is referring to something or nothing. Y just doesn't exist, so this is an error. Okay, next let's talk about functions. So a function in programming is a block of code that runs when it is called. A function in Python can take in 0, 1, 2, and multiple inputs, perhaps a variable number of inputs, and can return nothing, or it can return one result. If you want a function that returns multiple things, you can do that effectively by returning a single, you can return multiple objects effectively by returning a single list or a tuple. So here are some basic examples. Here we define, so when we define a function, we write a def and then specify the function name and specify within parentheses the inputs to the function. So this function is named n+1 and it computes, well, just performs some basic arithmetic and returns a number. This function is def, so defined as with the name is big, and then it takes in a single input and returns a true or false value depending on this if statement. I want to emphasize again that in Python, indentation is part of the formal syntax and therefore it is not optional. So here, when we define the function, we write def and then we specify the function name, and the function body was indented. This indentation is necessary, and if we don't do the indentation, then this just doesn't work because the indentation is expected. Okay, and when you write functions, it's important to remember that mutable function inputs can be changed inside the function, and when you do so, you want to be careful as to whether that is something you actually want in your function. So for example, this is a function, it's named f, and it takes in as input x, presumably a list, and it modifies the first element of the list and returns the modified list. Well, the problem with this function is that it not only returns the modified list, which is presumably the desired intended behavior, it also affects the input itself. So the list that was provided into as input, that list gets changed, and that may not be what you want to accomplish. So a different approach could be, given a list, you could create a copy of the list using the slice notation, and then after that you can modify the copied list and then return that. This way, the original input x, the mutable input x, does not become mutated, and that's perhaps what you wanted. Okay, so here, this is a demonstration of this result. So the list A, so let's execute this function definition. The list A was initially contained 1, 2, 3, then it became modified as a consequence of calling this function A. If this is something you wanted, then that's okay, but maybe this is something you did not want. In this case, well, if we instead define the list B and then use the function G, then the return value of the function G is the modified list, but the original list B itself is the unmodified original list. So maybe this is more likely to be what you would want when you define a function. By the way, Python is not a strongly typed language. So if you have experience with a language like C++ or Java, then those languages are what would be called a strongly typed language. For example, when you define a function, you need to specify what the variable types, input variable types have to be. In contrast, Python is not a strongly typed language. It's a dynamically typed language, so you do not have to specify what the inputs to the function needs to be. Now, the only requirement for the function to successfully execute is that the operations are legal. So here, when we define the function f of x, the only thing that we do, well, we do two things with x. we access the first entry, or we don't even access the first entry. We just execute this command. So this thing where we use the bracket notation and assign 1000 to it, that's the operation, the first operation that we perform, and then we return the x. So for any Python object, this return is going to be a legal operation. So in order for the function f to successfully execute, all that is required is that this bracket access thing is legal. We never specified that the function f takes in as input list, although that was inferred by the definition, but we can provide anything else so long as x can be anything else, so long as this operation is legal. For example, let's say D is a dictionary with two entries with keys A and B, well, we can call the function f with this dictionary D. And what will happen is this dictionary will get passed in as input. And then now this operation is, because the input x is now a dictionary, rather than a list, this operation is interpreted as we will be adding a key value pair to this dictionary. The key is going to be the number 1, and the value is going to be the number 1000. So instead of modifying the first element of a list, the meaning of this becomes we're going to access the key value pair with the key equal to 1, because the x is now a dictionary. And the result is a dictionary with the key A, B, and 1, and the values 1, 2, and 1000. So this might be troubling. You might find this troubling if you are very much accustomed to dynamically typed programming languages. If you come from a strong C++ and Java background, this type of behavior where this could be whatever, depending on this operation could mean whatever depending on what the input is. You might find this a bit troubling, but this is being allowed to do this is part of the Python spirit. So whether you agree with this or not, this is how Python works, and many Python users really appreciate this type of freedom. So if you are somebody who, if you're a strong proponent of strongly typed languages, you might consider something like this to be this dynamic behavior to be risky and dangerous and error prone. But in Python, people just do this, and people are happy with this. When you have a function, within the function you have separate variable names. So here's what I mean. In this program, so we initially define the function f of x, but after that we execute actual code. So x is equal to 5, and then we print x. We call the function f of x, and then we print x again. But this variable name x in the outside world, and there's another variable named x within the function definition. Now these two x's are distinct. They happen to share the same name, but they're different variables. This program is identical to this program. So here we replace the variable name x with the variable name y, and the program, the behavior is exactly the same because, well, these are just two. The variable names happened to overlap, but they really had no relationship to each other. But when the input variable x, when the input to a function is a mutable object, in the case of a list, then yes, this variable lst and this variable lst are distinct variables. They are distinct names. So I could change this name to whatever, and it would be the same exact program. But what I mean when I say the variables are distinct, I'm referring to the variables as names. So variables in Python are like pointers, if you're familiar with that notion from C++. They are names that refer to things. So in this case, yes, this name and this name is distinct, but the two distinct names in this case refer to the same object. So even though they are distinct names, they refer to the same object, so the change to that object within the function becomes visible from the outside world. In Python, functions can have default argument values, and this is the way this is done in Python is, in my opinion, quite elegant and convenient. So here we have a function that takes in 3 inputs, A, B, and C, or at least potentially up to 3 inputs, but the inputs B and C are provided default values 10 and 20. And the functionality of this is quite simple. It just prints out the inputs A, B, and C. But when we do this, now if we provide 1, 2, and 3, the output is print 1, 2, 3. But if I just provide 2 inputs, then the third input is inferred to be the default value. And then if I just provide in the first input, the second and third input are inferred to be the default values. And if I provide nothing as the input, then that's not allowed because A, the first input, or the first input A, there was no default value provided for that. Okay, so when you use these default inputs and when they are just initialized, set to be some immutable object, in this case numbers, then this is safe. But here's a common pitfall people fall into, and actually fully understanding this example is quite informative. So this is a subtle thing, but it's something people run. It's a mistake people often run into, and it's a good exercise for you to understand this completely. So let's go through this example, and I'll give you the answer a priori. So this is the answer, and it's probably not going to make sense at first, but let's go through this example so that it makes sense. The answer to this problem is that the default value for a function argument is only evaluated once at the time that the function is defined. Okay, so what does that mean? Well, let's take a look at this through an example. So here we have a function named foo, and it takes in as input a list named bar, but we define the input bar to be just some empty list. At least that's our intention. And the functionality of this function is to append another string to the list and return the string. Okay, so I think the intent of the author of this function is quite clear. The user of this function is allowed to provide any list, and let's do that. Okay, so let's test this one out. Okay, if the user provides whatever list, then SNU is appended to this list, and then that result gets printed out. So far, so good. And we can also provide the empty list, and when we do so, we'll just get SNU. So this so far is working good. Now, what's not good is that, well, the input bar, it has an associated default value. So let's utilize that feature. Let's execute this. Okay, so we provided nothing. SNU was appended to the empty list, so the output is a list containing SNU only. This looks like it's working well, but if we execute this again, we get 2 outputs of SNU, we get 3 outputs of SNU, we get 4 outputs of SNU, and you can see now the pattern. Every time I execute this function again and again, the output's going to have more and more SNUs added to it. This is maddening, right? This is madness. Why does this happen? Well, let's go back to the answer. The default value for a function argument is evaluated only once at the time that the function is being defined. So when this function was defined, so this operation is, what this operation means is this is effectively constructing a list object with no entries, and that this default value construction is evaluated only once at the time that the function is being defined. So what's happening here, every time I'm executing this command, well, this list that is used as the default argument is created once, and then it is being reused over and over and over again. Because what we want is that, what we intended is that when we provide no input to the function, we wanted this part, this default value initialization, to be re-evaluated again and again every time we execute this function foo without any inputs. But instead of that happening, this construction of the empty list happened once, and it will never happen again. And every time we append to this list, well, we are accessing, now the variable bar is referring to this same list which has SNU appended to many times. So instead, what we want to do is we want to, the solution to this is, it's not perfectly elegant, but this is what you would have to do, is if we provide a default value for the variable bar to be just none instead of the empty list, And if bar is none, so if no input was provided, then we set bar to be the empty list. And note that this list construction is now within the function definition. So now if we redefine the function this way, the function works as intended. Every time we execute this function, bar becomes the default value is used, the default value is none, and then when that is detected, we create a list. So this was a subtle issue, but I want you to understand this completely. Trust me, having a firm understanding of this issue is going to be hugely beneficial down the road when you write more and more complex Python programs. So let me explain this again in a slightly different way. So when I define this function, so here I select this cell, I press enter. At this point, the question is, how many list objects exist? And the answer is 1. One list object exists. One list object was created. It was executed, evaluated. This line was evaluated once when the function was defined, and this list that was created once, it will be used over and over again as the default value for the variable bar. In contrast, if I select this cell and execute, at this point, how many list objects have been created? And the answer is none. No list object has been created because yes, this function was defined, and this line was executed, but this part of the function body has not been executed yet. The function body does not get executed when we define the function. It only gets executed when we call the function. And at this point, we have not called the function yet, so 0 list objects exist at this point when I just define the function. So this is a subtle issue. Make sure you understand it. I'm going to move on. Now here's another related but mistake. So if you, all right, so here, if I define the current, so here I'm going to define a function named print time, and there's going to be a current time input, but perhaps I want to assign I want the default behavior of print time to be print the time of execution. So I define this function, and if I execute this print time method, it's going to say the current time is this, but if I execute it again, the current time never ever changes. But if I redefine this function and then execute it again, now the time has been updated. Let me do this again, execute this again, and execute. Now the time has been updated. So again, the issue is that this default value initialization, this gets evaluated only once when I define the function. So this functionality, which comes from the module datetime, it allows us to retrieve the current time on the clock, but this only happens once when we print the time. So this is essentially the same kind of error as this one, but with a different sort of a flavor. So so make sure you understand this, and here's a question. So how would you fix this issue? So just a simple exercise, but it would be worth going through. So next we have keyword arguments. So previously we defined functions and then we called them by providing the inputs. But when we provided the inputs, we had to make sure that the inputs were provided in the correct order. So these type of normal arguments are called positional arguments because the order in which we provide the arguments, the position in which we provide the arguments matter. In contrast, functions can also be called using keyword arguments in the forms of keyword argument equals value. And keyword arguments, this is a long name, so people often abbreviate it in this way, KWARG, and people often just read this out loud as kwarg. And so the sound kwarg sounds a little bit silly, but it's a commonly used phrase in Python, in the Python community. So I will be reading this as kwarg. Okay, so here's an example. We define a method. We define a function called parrot, and it takes in as input voltage, stage, action, and type. And it does stuff. It prints stuff. It's a silly function, but whatever. So voltage, state, action, type. Those are the 4 inputs for this function. And voltage is a required argument because we don't specify a default value, but for state, action, and type, there are associated default values, so we don't have to provide them. There are several ways to call this function, so we can do so. One option is to just provide all inputs, right? So we define the method function first, and then we call it. But we can just provide the voltage because as a single positional argument, because this is the only input for which a default value is not provided. But instead of using a positional argument, we also can use a keyword argument. We can also use a quark. So so voltage equals 1000. We explicitly specify the name of the input and we provide the value. We can also have multiple keyword arguments, multiple quarks, and this also works perfectly fine. Now, note that here we are providing the voltage and we are providing the action. We are not providing the state and the type. Now, something like this would not be possible if we were to just use positional arguments, because if we were to, let's say, do something like this, just this and this, okay, so if we were to do this, then, well, this number has to correspond to the first input, this thing has to correspond to the second input. But what we wanted is we wanted to provide the voltage and the action while using the state and the type variables, the default values for those, the state and the type inputs. But that's just not possible. So if we want to, especially when a function comes with a lot of default values and we want to selectively choose to provide non-default values, then this type of keyword arguments becomes essential. Okay, so here we can provide the voltage and the action, or we can provide the action and the voltage. And in fact, this is another advantage of using quarks, and that is that we don't need to remember which order that the variables are specified. So if we use positional arguments, then the position does matter. So whenever we call the function, we need to go back to the definition of the function and try to recall what was the order in which the variables were specified. In this case, it's voltage, state, action, type. But why do I have to remember that, right? And perhaps for some reason it might be convenient to specify the inputs in a different order. Well, when you have positional arguments, that's just not possible. But if you're using quarks, then it is possible. You just specify the names in different orders. And but when you're using quarks, the meaning is completely clear, so you're allowed to specify in any order. It's also possible to mix positional and keyword arguments. So here the first input is positional, so it's understood to be the voltage, and then we provide whatever other argument as a keyword argument, and this also works. Now, what doesn't work is if you want to mix positional and keyword arguments, then the quarks must come after the positional arguments. In this case, I'm trying to do something like quark before a positional argument, but that just doesn't work. And also, what doesn't work is so if I try to execute this, it's just not going to work, right? It says positional argument must follow keyword argument. Now, but if I try to do something like this also doesn't work, kind of obviously, because in the function parrot there are 4 variables: voltage, state, action, type, and well, there's no variable named foo. So what would this even mean, right? So you're not allowed to specify a keyword argument that doesn't match any of the names of the function, quite obviously, and indeed this doesnn work. Okay, next let's talk about unpacking an argument list. So here we have a function named fn, and it takes in inputs a, b, and c, and it does whatever. So let's take a look at its execution. It takes in a, b, and c, and it adds the 3 inputs and prints it out. Or to be more precise, it uses the plus operator with the 3 inputs a, b, and c, and prints out the result. It's not necessarily addition. Now let's say we have a list named lst, and we want to provide the contents of this list as input to function fn. So one option would be to do fn lst 0, comma. So we could do something like this, right? So this would certainly work. And what this does is it extracts extracts love, the three strings from this list and provides them as input. And then the function fn takes in the three inputs and uses the plus operator on the three inputs. In this case, the inputs are strings. So the plus operator, the meaning of the plus operator is concatenation. So, and prints out the result. So the result, what's printed out is the three strings concatenated out. We love you. How lovely. But this is quite cumbersome, isn't it? We explicitly had to extract the three elements one at a time from the list LST. So wouldn't it be good if we could do something like this? Just call the list, just provide the list as the input. But this doesn't work because, well, this shouldn't work, right? Because the function is specified to take in three inputs. And here, yes, I understand what you're trying to do, but LST is just a single object. It's a single list object. So we should not be allowed to provide just a single list object when three inputs are expected. So instead what we can do is we can use the unpacking notation. We can use the star notation to unpack, in this case, a list. So instead of this, we can do the star list. And now this will allow us to automatically unpack these three elements into the function fn. And we get the desired result. The star notation can be used with both list and tuples. We haven't talked about tuples yet, but to just provide a quick demonstration, this tuple contains the numbers 1, 2, and 7. And if we do the unpacking, it works in the same way. So 1, 2, and 7 are added, and the output is 10. Okay, so if we just provide a single input, whether it's the list or a tuple, that's going to be an error because three inputs were expected. We provide only one, but if we use this unpacking notation, then it works out just fine. Now, when we can do a similar thing with keyword arguments, with kwargs. So here we have a function named parrot. It takes in three inputs named voltage, state, action, and it's the same silly function. In any case, so here we define a dictionary named D. It takes in, it has three entries. It has three value pairs. So the three keys are voltage, state, and action. And note that these three keys, they match the name of the variables for the function parrot. And then the values are whatever. There is some values. Now, when we want to unpack a dictionary in the form of a keyword argument, we use the double star notation. So we do the double star D, that unpacks the dictionary, and now the contents are unpacked and they are now understood as keyword arguments. Okay, so this thing works, but if I change in this case, the key for the key voltage, now this does not work because there's no variable named voltage 3 in the definition of the function parrot. And again, same as before, now that we're using kwargs, the order in which we provide the inputs doesn't matter. And in fact, when we define a dictionary, the order in which we define the key value pairs, the entries of the dictionary, shouldn't matter at all. So this is the same dictionary as before, and we get the same result as before. The order in which we specify these key value pairs has no effect. So next, let's talk about tuples. So tuples are immutable, and they are usually used to contain a heterogeneous sequence of elements that are accessed via unpacking or indexing. In contrast, lists are immutable, and their elements are usually homogeneous, and they're accessed by iterating over the list. So tuples and lists are share a lot of commonalities, but they have one objective difference, and the objective is the mutability property. Lists are mutable. Tuples are immutable. But the more essential difference between tuples and lists is in how they are usually used. So tuples often contain a heterogeneous sequence of elements, while a list contains usually a homogeneous sequence of elements. As discussed before, this is not a formal requirement. A list can contain a heterogeneous sequence of things, but often it's used to contain a homogeneous sequence. And a tuple is usually accessed via unpacking. So one unpacking option is to use the unpacking for the function argument. That's one option. But there's also another type of unpacking that I'll discuss soon. And also, elements of a tuple are accessed via indexing. So by accessing explicitly the 0th, the 1st, the 2nd elements of a tuple. In contrast, elements of a list are usually accessed by iterating over them, often via a for loop. So the elements of a tuple can also be accessed via a for loop, but that's not that common. It's usually lists that you do that with. So here is an example. So let's just first look at this. So X is now a tuple, and here a tuple is defined with parentheses. So again, parentheses is the notation. It's the syntactical notation in Python that's used to define tuples. So brackets, that's for lists. Curly braces are for dictionaries, and parentheses are for tuples. This tuple contains 1, 2, 3, and then 4 distinct elements, and they are of heterogeneous type. So the first is an int, the second is an str, the third is a list, and the fourth is a dictionary. So let's do print x. So if we print out the list, it prints out all the elements. Now what we can do in order to access the elements of a tuple, we can use what's called tuple unpacking. So here we have a, b, c, d is equal to x, and this can be used to access the individual, to unpack the tuple and get the individual entries. So a is 3, and let's say d is the dictionary, and c is the list. When we perform tuple unpacking, perhaps from a beginner's perspective, this notation is would be more natural. So x is a tuple, and we assign that to another tuple containing the variables a, b, c, and d. And this is perfectly legal, and you will often see people do this. People will often use the parentheses when when performing an unpacking operation, but people often don't do this. So it's often just more convenient to not have parentheses, because to write parentheses you need to type. You need additional keystrokes, you need to type in additional characters, and sometimes people just don't bother. Okay, so here we do the tuple unpacking, we print a b, so okay, we can access b and c in this way. Here we can also explicitly access the entries of a tuple, so this is the 0th element, this is the first element, this is the second element, and the second element gets printed out by this command. And okay, using tuples, you can perform what's called multiple assignment. So you can conveniently assign multiple variables in one line, and this is a very Python thing, and I like it. So if you want to assign 1 and 2 to a and b, so you can do something. Excuse me. You can do something like 1, b, 2. You can do something like this, but sometimes you might want to combine this into one line, so you can do what's called multiple assignment. So a comma b is 1 comma 2. You can also write this with parentheses, but why bother? So this is without parentheses and with parentheses. So both are valid multiple assignment operations. And tuples are immutable. So what I mean by that is a tuple, when it's created as a tuple of a certain length, and the individual elements are reference variables. They refer to a certain object, and that does not change. But the objects that elements of a tuple refer to, they can change. Let's take a look at this example. Okay, so here's a list. A list is a mutable object, as we've established. And let's have a tuple of length 2. So pair 1 is 3 comma list 1. And let's print this out. Okay, so 3 comma a comma b, right? So this pair is a tuple, and it is immutable, meaning in the 0th entry of the tuple will refer to an int object with value 3, and the fact that this reference will never change. And the first element of the tuple will refer to this list, and that fact will never change. Pair pair bracket 1 will forever refer to this list, and that will never change, the list throughout the lifetime of the program. But we can change this list. So the pair 1 bracket 1, yes, will forever refer to this list, but this list can change. And when we do so, when we change the list, then even though the tuple did not change, even though the tuple is and has always been immutable, the content of the list of the tuple did change. So this is again a subtle distinction that I'm repeating many times, but I do want you to really have a firm understanding of this matter. And finally, a tuple can also have length 0 and length 1. So to create an empty tuple, you just have open close parentheses, because how else would you define a tuple of length 0? If you just have nothing, well, that's not going to work, right? So in order to have an empty tuple, you can just open and close parentheses, and that'll be your tuple. When you're defining a tuple of length 1, then you can have parentheses, and you can just have 1 comma nothing, and this will give you a tuple of length 1. Note that if you do this, then this can't work, because how would Python know that this pair of parentheses is meant to delimit the beginning and an end of a tuple? Python just has no way of knowing. It might be just, maybe you're doing this, so you want parentheses surrounding some arithmetic operations. So in order to make clear that you're trying to define a tuple here, you are required to provide a comma. And there's another way we could check this. So if we probe the type here, we get a tuple, but if we don't have the comma, we just get just the number int. Now when you're having a tuple of length 1, then you're not required to provide the parentheses. You can just write 1 comma and you'll get a tuple. So if you're not familiar with this type of tuple notation, then sometimes you'll be reading other people's code and you'll just encounter something comma and then nothing, and then that could be a little bit confusing. So remember, if you have something and then just a comma without any other context, that the program is creating a tuple of length 1. And to remind you, if you want to have a longer tuple, then you can just have a bunch of stuff separated by commas, and there's no need to surround them with parentheses. So the use of parentheses is mandatory when you have a tuple of length 0 for obvious reasons, but otherwise, even for a tuple of length 1, you don't have to provide parentheses. The next data structure to talk about is the set. So in Python, a set is an unordered collection of items. Every element is unique, so no duplicates are allowed, and the elements must be immutable. However, the set itself is mutable, so you can add and remove elements from the set, but whatever is added to the set, those elements must not change. They must be immutable. Why it is that the elements of a set must be immutable? Well, to be more precise, elements of a set must be hashable. There must be an associated hash function that you can call with those elements. And mutable objects in Python tend to not have a hash function available. So in any case, here we define a set. And when we define a set, we use the curly brace notation. So actually, the curly brace notation has two distinct uses. It is used to define a dictionary, and it is also used to define a set. So here we have a set that is defined to include 1, 2, 3, 4, and we specify 3 and 2 in a duplicate way, but because a set is defined to not have any duplicates, the elements 1, 2, and 3 are included only once. We can also define an empty set by just having a set here. So if we were to use the curly braces instead of set, then what would happen is the empty curly braces will be interpreted as an empty dictionary. I suppose that's because curly braces are used more often to define dictionaries than they are to define sets. So if you want to define an empty set, you need to call the set constructor with no elements. So again, a set cannot include a mutable item. A list is a mutable item and therefore cannot be included in a set. But a tuple, in contrast, is not mutable. It is an immutable item, so a tuple can be included in a set. And also a set is an unordered collection of items. A set is an unordered collection of items, so it doesn't make any sense to access the 0th element. As there's no, a set does not support indexing, so you're not allowed to access the elements of the set in this way. Okay, so to create a set, to modify a set, to add elements to a set, you can use these kind of operations. So this creates a set. We can add a single element to a set. We can add multiple elements to a set, and we can print elements from a set. Now here's an exercise. Determine the number of unique letters in this string using a set. So here's, I'll show you how to do this. So s is equal to this string. And then we'll use a for each loop. So for all characters C in s, what we'll do is we'll create a set. So this set is an empty set. And then we'll do st.add c. And then finally we'll print the length of st. So the next topic is string formatting. So string formatting perhaps doesn't sound incredibly exciting. Indeed, there's nothing intellectually challenging about performing string formatting. It really is indeed a menial work. But nevertheless, it's a very important topic. We use it, people use it all the time. It's absolutely necessary for you to be comfortable with string formatting in order to write code and retrieve information from your results from your program in a way that you can understand easily. Okay, so let's take a look at this example. Here we have a dictionary named person. So this dictionary describes attributes of this person. So we have the name of this person, we have the age of this person, and then we can imagine including a lot of other further information about this person in this dictionary. Now, if I want to print out, so let's just see the result. Okay, so let's say we want to write, my name is Alice and I'm 20 years old. And the name Alice is retrieved from this dictionary, and the age 20 is also retrieved from this dictionary. So what you can do is you can write my name is, and then end the string, and then perform concatenation with the name of the person, and then do concatenation and I am, and you need to make sure that you have spaces here. And then concatenate the age of this person, but the age of the person is an integer, so you need to convert that into a string with the str function, and then concatenate and make sure you have a space here, and then you can have this stuff here. This is fine. This is something you can do, but it's a bit cumbersome. And anybody who's ever tried writing a string output that looks like this can relate to the struggle of making sure you have spaces here and then having the pluses here. This is just cumbersome and also error prone. So it's much easier to do something like this. So my name is blank and I'm blank years old, and then using this format option. This is a much cleaner option. It's much less error prone, and I think it's much more readable. So if you compare this code with this code, I think this line, it's much shorter. Well, it's not much shorter, it's a few characters shorter, but in my view, it's it's easier on the eyes when I try to read this code. So there are a lot of string formatting features in Python, and for that matter, any other language, because there are a lot of cases, needs for effective string formatting. We're not going to go through all of them. We'll just go through a handful, just the bare minimum that you would need in order to be functional, to be able to work with things in Python. So this is basically the most barbaric way to perform string formatting. So this wasn't how some people did do this, but this wasn't the most efficient way in Python. There used to be a different type of formatting using the percent symbol, but I'll tell you about the str format syntax, which was introduced in Python 2.6. So prior to Python 2.6, there was a different approach, but I'll skip over that. So, okay, so the way string format works, str.format works, is you in different places of your string, you open and close curly braces. And these curly braces, open, close curly braces, are positions in which you will be performing substitution. So here I write curly brace 0, curly brace 1. So here I'm saying this is the 0th position, this is the first position. And then in the format method, I'm going to provide things. So here I'm providing a string, here I'm providing an int. In any case, I'm providing the two things, this in the 0th position, this in the first position. And And here, this is replaced with what comes here, and this is replaced with what comes here, and we get my name is Alice and I'm 20 years old. Okay, cool. In the previous example that I'd shown, there was no numbering to refer to the positional arguments, and that was fine for that particular example. But if it is the case that you want to perhaps restructure the sentence and you want to say, I am X years old and my name is blah. If you want to do this, then, and if you didn't have these numbers indicating the positional arguments, then this would be incorrect because this is inferred to be the 0th position, this is inferred to be the 1st position. Well, now you can swap the order of these, which is possible, but it's a little bit error prone. So it's actually better in this case to explicitly number the positional arguments. So number 1 is the first input and 0 is the 0th input. You can also use keyword arguments with the format method. So my phone number is, let's just execute this. So here is an example phone number. This is actually a US phone number. So this is the area code. This is what's called the central code. This is the station code. And this is the separation that some people use the dash for the separation, but this is just to separate the numbers. So my phone number is area code, central code, station code. So I specify the area code, central code, station code, and I'll also specify the separation delimiter. So if I want to, in this string, change the dash to just a space, then I can replace it with a space, and then there you go, that's the phone number. Or maybe I don't want to separate my numbers at all, just print them raw, so this could be another way. I could also use a period. I think this is the European style of separating numbers. In any case, you can put whatever separator you want. Okay, and here, so the benefit of having these keyword arguments is that now a single input to the format function can be repeated multiple times. Having the separator repeated twice is only possible because we use these keyword arguments. Okay, and you can also access the the list and dictionary entries using the bracket notation. So here, person is a dictionary, and we here what this in the curly braces we mean from the 0th element we're going to access the thing with name, the value corresponding to the key name, and indeed that works. So my name is Alice and age is 20. And we can also perform a basic arithmetic, not within the string, but we can do something like this. So here we have a radius. The circle has radius something, and then here we have radius r squared times pi. So we perform the computation here within the input as the input of the format method, and it gets printed here. Now here, if I were to just print out the result, then we get a lot of decimal places because this is a float with a lot of trailing digits. But if you want to clean things up, then there are various ways to format numbers and also other data types that come with these with the Python libraries. And I won't go through the details, but what this means is that so what we have here, this is in this case maybe I'll say 1. Whatever we have when I write colon means I'm further specifying options in displaying the string, and in this case I'm recognizing this data type as a float, and I'm specifying that after the decimal point I'll be printing 2 digits. So if I do this, after the decimal point I'm printing 2 digits. There are other fancy formatting options, and which you can take a look in this link, but I'll stop here. Okay. So that's how you can do string formatting using the str format function. But a more modern approach is, and this approach is actually a little bit too modern, so this is not used universally, but fstrings. So fstrings is a more, in my view, a significantly improved string manipulation tool that was introduced in Python 3.6. Python 3.6 is not too old, and because it's not too old, because it's quite recent, you will still see a lot of people using the str formatting method. But for the code that you write, that I recommend using f-strings instead of the format option. Okay, so in order to write an f-string, what you do is before the string, you prepend the character f here. The character f can be lowercase or capital. It doesn't really, the case of f doesn't really matter. And what you do is, within your string, you can just write, have curly braces and just write the variable name. So whatever is within here is understood as a Python expression that will be executed, and then after that, the output will be converted into a string. So okay, so here, hello name, you are certain ages old. And in my view, this is much more cleaner compared to this format syntax. You can have different opinions, but I prefer the f-string syntax over the str format syntax. And with f-strings, you can also have things like this. So here, let's say Eric weighs 150 pounds. So Eric weighs this many pounds, sure, but we can also perform arithmetic, or we can, for that matter, have a Python expression that is to be evaluated within the curly braces. So this gets evaluated, the return value gets turned into a string, and that gets printed out as a result. Now, as before, we may want to make this look a little bit more tidy. So we can specify the formatting options. So this is the thing that we're going to print. This is the expression that we'll be printing. So this expression will be evaluated. The return type is going to be printed. But after colon, we'll specify the formatting option, and we're saying we'll print out we recognize this as a floating point number, and we'll print 2 digits after the decimal. So we get this, much more cleaner. Okay, next, let's talk about some useful built-in functions for manipulating sequence elements. The first function is enumerate. So imagine we have a list that looks like this, and we want to iterate through the list in a for loop, but we also want to have a counter associated with it. So we want to, when we execute a loop, we want to get 1 and tick, 2 and attack, and 3 and toe. So we want to do something like this. Well, a clumsy way to do this would be to do, let's say, for s in L. So if you just do print s, then we would just be printing out these things. A clumsy way to do this would be to have a count equals 0, and then a count plus 1, and then print count. So we could do this. We're having a separate counter, but this is a bit cumbersome. So instead, what we can do is we can use enumerate. So let's do print list enumerate L. So when we do this, then we get 0, tick, 1, attack, 2, 2, toe. Now, so the list L used to contain 3 strings, but now our enumerate, once we use enumerate, we get a list that contains 3 tuples, and each tuple contains an int and a string. So now we can write for iv. We can write iv in enumerate L, and then print I, v. Okay. So we can do this, but perhaps we don't want to start with counter 0. Maybe we want to start with a different counter. In that case, we can do comma 1. And if we do that, then as you can see, our list now contains 3 tuples, and each tuple contains an int and a string, and the int counter starts at 1. So here we have a for loop where I, v, the tuple, belongs to this enumerate object. This is it's an iterable object. But when we write this, the parentheses are not necessary, so we can just omit them, and we get the same exact result. Another useful function is zip. So zip combines lists into an iterable of tuple. So let's say we have 3 questions in a single list. So name, quest, favorite color, and there are 3 answers, whatever, whatever, whatever. So if we want to have, if we want to be able to loop through a pair of answers and questions, then a nice way to do so is just use the zip function. So let's first see what the output of the zip function is. So print a list zip. Okay, so the 2 lists used to contain 3 strings each. Now when we zip them together, the zip is, I think, in reference to zipping up a zipper. So it's like zipping up these 2 strings into one string, 2 lists into one list. So 2 lists get combined into a list of 3 tuples, and each tuple contains 1 string from the first list and another string from the second list. So when you do this, we can have a for loop. With these Q&A pairs, and as before, again, we don't need the explicit parentheses in specifying this loop. Okay, if you have a list or some sort of iterable thing, then you can reverse it with the reversed command. So let's take a look. So print L. So this is our list, but if we do print list reversed L, then it's reversed. So if you want to iterate through a list in a reversed order, then this is how you do it. Okay, so we can print things in a reversed order. And by the way, you can achieve the same thing using slice indexing. So I'm going to slice from beginning to end, but I'm going to step with -1 as my step. That way I'm going to step backwards. So this has the same exact effect, but and some people can prefer using this slice notation, but this reverse method is, I think, more readable. So I think this is a slightly better form. And when you have a dictionary, you can iterate through the contents of a dictionary with the items method. So here is a dictionary. So it has 3 entries. The keys are 1, 2, and 3, and the values are Jan, Feb, and Mar. And you can iterate through the key value pairs by taking the dictionary and calling the items method. Next, let's talk about the del statement. So the del statement is used to remove variables, and it is also used to remove elements of lists. So let's take a look. So here we have a string s, and if we print the string, we'll get the string. But if we use the del keyword to delete the variable, well, then the reference variable s has been removed. So the name has been removed. Let's take a look at another example. Okay, so here A is a list of numbers, and if we print it out, this is the list. A refers to the list, and the list these are the contents of the list. Now, if I want to delete a particular element from a list, I can use the del keyword, and by doing this, I'll be deleting the second element from this list, and now the second element is gone. I can also delete a range, so from 1 to 3, so from 1 up to 3, those elements will be deleted, and now I'm left with 0 and 4. I can also delete the whole thing. So here I'm not actually deleting the list, but rather I'm deleting all the contents of the list. So when I do print A, it's going to print me an empty list. So through this command, I deleted everything within the list, but the list still remains. And then if I delete A, well, then now that's not allowed because this deletes the list itself. So or to be more precise, it deletes the reference variable A itself. So the reference variable name A is no longer defined, and I'm not allowed to access it. But to be a little bit more precise, the del keyword deletes the reference variable, but not necessarily the object itself. So in this example, there exists one string within this code. So A is a reference variable referring to the string object, and B is also a reference variable referring to the string object hello. So there's one string within this program, and there are two names associated with this string. Now, if we delete A, what this means is that we are deleting the name A. The name A is going to be removed, but the string object is not. So if you do del A then print B, then this is perfectly fine because yes, the name A has been removed, but B still persists. So the name B is still perfectly fine for us to use, and it still refers to this, this string object hello. If we try to access A, of course that's not allowed because we just deleted the name A. The name A has been removed from the system, but the name B still exists, and the del keyword was always about removing the name. It was never about removing the object itself, so there's no problem with accessing the string object with the name, with a persistent name B.